Or no, this is fuchsia. Sorry, fuchsia. So what do we have going on here? I'm taking this problem directly from the book. Okay, so this is football. Football. That's quite a hideous football. It's football, and it's got a mass of 0.5 kilograms, and it's moving with a velocity of velocity of 15 meters per second in this rightward direction, to the right. 15 meters per second. And we're not even going to look at gravity, because gravity makes it ugly. And we're going to say that it's moving at that speed right as it's hitting some guy's glove or whatever. I'm not going to go into details with the glove because I failed that last time. So that's our glove. That's what our glove is. Wait, what? What? I'm sorry. I'm mixing up baseball and football. Into some guy's hand. You can tell that I'm such an artist. He does not have 6 fingers. That's an illusion. This is actually 5. That's 5 fingers right there. Crap. I'll finish this video. Or I'll finish this lesson or whatever in the next video. So I'll see you then. Running out of time. Hello, sorry. I keep getting kind of cut off a little bit at a time, but like we said, so where we left off, I was showing you that this is actually 5 fingers, even though it looks like 6. So he's getting ready to catch this football, and when he catches it, he brings it to rest in 0.02 seconds. That's how long it takes him to catch it and slow it to a stop, which is not very long. But we want to find out how much force is he applying to catch that. And you figure actually, depending, we could actually figure out how much work he's doing or how much energy he's using. But I'm not going to get into that because that's going to be an annoying problem. In fact, we'd actually need a little bit more information. But anyway, so how much force is he exerting on it? Okay, well, let's, and then we'll actually probably, we'll figure out, do I want it? Nah, I don't want to do that. How much force is he exerting on it? Okay, well, let's start with what we know. Let's look at our momentum, because that seems to be a common factor here. It seems to appear in a lot of things. We'll define our initial momentum. What's our initial momentum? That's mass times velocity, and that's just equal to 0.5 times the velocity is 15 meters per second. So we end up getting 7.5 kilogram meters per second squared. Or, I'm sorry, kilogram meters per second. And what's our final velocity? This is an easy one. He's bringing it to rest, right? He's bringing the velocity to 0. So the final momentum is 0. Again, that's a relatively easy thing to calculate. It's just simple multiplication. No, this unit is actually very simple mathematically. It's very it can be annoying with the way that they word them the problems, but I think you can get through it all right. So these are our initial and final momentums. And what else we have? Well, we have that interval of time, right? So we know that the change in time, and the reason it's written like this is because actually say this is a football game, and he starts to catch the ball at when there's 3 minutes and 48 seconds, or 48.39 seconds on the clock. And then he finishes catching it when there's 3 minutes and 48.37 seconds on the clock. So that's just how long it takes him to slow it down to a velocity of 0. And yes, I'm aware that most football clocks do not go into that precision, but let's not go there right now. I wonder if I can pause this recording, by the way. That would be convenient for me right now. Okay, sorry, I had a text, and I have the attention span of a squirrel. So where were we? Oh yeah, so we know this interval of time. We know how long it took him to change the momentum from 7.5 to 0, right? He had to he had to take that momentum down from 7.5 down to 0 in this amount of time. So what's that equation that we know? We know that the force that you apply times some interval of time that you apply it over, the force times some interval of time, gives you the change in momentum, or the final, well, in this case I'm just going to, sorry. The final momentum minus the initial momentum, and that just gives us, well, it gives us a negative 7.5. I'm just going to ignore the sign because signs just are not truly important in momentum, at least not in this case. So we get 7.5 was our change in momentum, or our force times our interval of time. So force times, we said at 0.02 seconds, that's our interval of time right there, 0.02, is equal to 7.5. Solve for the force. We get that the force is equal to, calculator button, hold on. I love that, it's so convenient. 7.5, whoops, clear. 7.5 divided by 0.02, and we get 375. Why does that look wrong? Is that, yeah, no, that's right, okay. So we get 375. So the force is 375, and that's in newtons, of course. Yeah, by the way. That's the force that he applied to slow the ball down from 15 meters per second to 0 meters per second. Or rather, that's how much force he used to take an object with this much momentum and take down its momentum to 0. So hopefully that makes sense. Hopefully these past 3 videos have given you a good idea of how to approach a lot of the basic momentum and impulse problems. Just remember that momentum is how much you don't want to get hit by something. It's how massive it is times how fast it's moving at you, and then the impulse, or the change in momentum, is just equal to some force that we apply times however long we're applying it for. So these are the 2 things that I want you to get out of this video, and also I want you to understand what they are, where they come from. If you don't really get any one of them, either watch the video again. If that still doesn't help, let me know, because I really want you to understand these, because these are pretty, they get to be pretty important, especially when we get into things like angular momentum, which is, it's not that much more annoying, but the calculations can become obnoxious just because of the fact that it's in a circle. But anyway, I gotta go convert these videos correctly now and play with my tablet a little bit more. But I should be uploading these soon. I'm contemplating whether to upload them now or whether to wait till the end of the chapter. I'll probably just upload them now and get them out of the way. But hopefully these were helpful. My next video, what's it going to be on? Let's do the fucking cool next. I'm going to do the right general thing to approach conservation of momentum. It's kind of annoying, but it's not too bad. So I'll see you then.